Hello, intermediate algebra students. Today we are looking at 5.3 day one. Today should be pretty quick. We're just getting the beginning portions of scatter plots and line of best fit out there today, and it's not very heavy with work involved. Day two, which is going to be on Monday, I will be back. That's going to have a little bit more work involved. But today, kind of just covering our bases and getting into what scatter plots really talk about here and what lines of best fit really even look like. So a scatter plot, we've been spending all this time talking about lines, and every graph we make is a straight line, and everything comes out nicely. With scatter plots, this is much more realistic, where in the real world, with a whole bunch of data, typically it's kind of all over the place. And what we look for in certain sets of data are trends. Are things trending up? Are they trending down? Do they not have anything to do with each other? The X and the Y variable, things like that. We'll get into that conversation here today and Monday. But really all we're looking at is there's going to be stuff just scattered on our graph. So that's called a scatter plot. And we're just trying to see kind of what it tends to look like it's doing in general. Okay, so whenever you have a vertical table of points, like this one here, the X value is always the left side, the Y value is always the right side, and you can tell that by looking at the age is on the X-axis. That's right here on the left-hand side of the table. Height is on the Y-axis. That's on the right-hand side of the table. So these are really just ordered pairs is what you're looking at. So 3, 1 is your first point. So what you're doing on this these first couple problems on Alex is you are just plotting these points. I did 5, 3, there's 8, 6, then 11, 8, 12, 10, and 14, 13, right about there. Now, this scatter plot is even a little bit not exactly realistic, but kind of what we can tell here is that they don't go up at the same rate or make a straight line all the way through. That's what you're going to see with scatter plots. If you look, this is a rise of 2, a run of 2. That'd be a slope of 1. So if that were to continue, this is where my points would be in green. And it would make a straight line through those green points. And as you can see, not all of the red points are on that line, right? So what happens with a scatter plot is you're just going to plot the points. They're ordered pairs. The left side is your X, the right side is your Y, and that's your scatter plot. And for the first couple of problems on Alex, all you're doing is plotting your points. That problem is done right now. You plot those points based on the table of ordered pairs, and that problem is done. Now, what we're actually going to do with these scatter plots is, for the most part, you're going to be given scatter plots. So the data points on the scatter plot below show the weight and fuel efficiency for each of 21 vehicles. So there's 21 points on that graph. Draw the line of best fit for these data points. It does not have to be the exact line of best fit, just draw your best approximation. So there's not technically one right answer here on Alex, but the line of best fit, the way that I can best describe that, is the line that you can draw that goes through what you think is the centermost point of all the data. Now, what we're talking about there is we see this big cluster of points. They clearly don't all connect to make one straight line. Your best guess as kind of the middle of all that data is what we're talking about with the line of best fit. Okay, something like that. Now, a couple misconceptions about the line of best fit. First of all, let me actually add a point in here. So, line of best fit. Couple things. First of all, does not have to hit any certain number of actual points. Okay, so you don't actually have to hit any of those points. Your line of best fit might not come in contact or go through any of the points that are already on the graph. Okay, it certainly does not have to connect all the points. It 99% of the time will not. Okay? But it does have to be a straight line, and we're going to talk about that misconception here in a second. Okay? So those are kind of the three main problems that we see when we're doing the line of best fit. So first of all, let's talk about that first one. It does not have to, let me kind of, I missed a word there, does not have to hit or go through any certain number of actual points. So your line of best fit, you might just go right through everything and kind of split everything right down the middle. You might not be going through any of those points. But I would say our line of best fit is somewhere in here. So as you can see, that is a pretty good approximation of all the points. Okay, there's kind of, it looks like the same amount of points below the line as above the line. None of the points are really too far away. Could you come up with something slightly different? Could it look more like this? Absolutely. There could be multiple answers that are a fair representation of the data. There's not one correct answer when we're talking about line of best fit. There could be a few. But the mistake that we often see is people think when I say split the data in half, they think they're going to count, well, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 21 points. 11 is like half. I'm going to draw a line right there. Okay, we're not looking to cut the data in half and separating it into two parts just by the number of points. We're looking for a line that represents kind of the average of the data, right? So we're talking about a line that's going through the actual values. I don't care about how many points are to the left or to the right of it, or how many points are above or below. That's not what we're concerned with. We're concerned with the actual values of these points and a line that kind of goes through and represents what kind of the average of all of them is. So either one of those, the red or the yellow, would be just fine. Those two would be great approximations. Now we're going to get into actually what we're doing with those lines on Monday. And then here, again, all you're doing on these problems for the line of best fit, you are just coming up with something that goes through what looks like the middle of all the data. Again, the one in red, could I come up with something different and still be considered right? Absolutely. Something like that would be just fine as well. Neither of those are bad. Okay, one might be a little more accurate than the other. Maybe the red one is a little more accurate here, but the yellow, excuse me, you could make an argument for the yellow being the accurate one either way. There's not one right answer, but all the answers are going to be pretty close, right? The red and the yellow line there aren't very different. Here, they're not very different. They're very similar, but you can see how they're going through that data, okay? So here, when you actually have that line of best fit already given to you, you're asked to fill in the blanks. When all you have is a graph and a line of best fit, you are using that line of best fit for approximations, okay? So here, when they say, for these 21 students, as the number of hours increases, the amount of money spent tends to what? Well, as the number of hours goes up from left to right, is our line going up or down? Are those points going up or down? It is increasing as you go left to right. So the answer to that first question, as the hours worked increases, the money spent increases. And I just put too many S's on increase. There we go. Increases. Okay. And then the second question, for these 21 students, there is blank correlation between the number of hours worked and the amount of money spent. So correlation is a separate little term that we'll spend a little bit more time on as the chapter goes here, but correlation is positive correlation is while x goes up, y also goes up. Negative correlation is as x goes up from left to right, y is going down. So they're doing the opposite. And then it is possible to have no correlation as x goes up. Notice all three of these are saying as x goes up. That means as I'm looking at my graph from left to right, the positive correlation means my y would also be going up from left to right. Negative correlation means as my x is going up from left to right, my y is going down. So that's like a positive slope, negative slope, same thing. And then no correlation at all is as your x is increasing, the y has no pattern. Okay, we'll talk a little bit more about correlation as we go here. But when we're talking about correlation in this situation, as x goes up, we already established in part A that y is also going up. So if they are going up from left to right together, that would be a positive correlation. And then using the line of best fit, so they're specifically telling us to use that line on the graph. We would predict that a student working 12 hours would spend approximately how many dollars? So this is where we get the biggest mistakes happening on these questions, is people look at 12 and they look for that first point. That's not what they're saying. They're asking you to use the line of best fit and the average of all the data. So if someone works 12 hours using the line of best fit, we're going to look at that point right there. It's not quite at 30. I'm going to go ahead and say 29. 30 would be right at that intersection there. I'm going to go ahead and say $29. And I'm going to tell you right now, I am not exactly sure. So it's a drop-down menu on Alex. They're not going to give you like 28, 29, or 30. They're going to give you three pretty different values. Maybe 30 is the answer here, but if 30 is the answer, the other two would be something like 15, 30, or 45. They're not going to be three numbers right next to each other, and you have to try and guess when they're all that close. So I'm going to say 29, could be 30. Okay, whatever Alex is giving you there on the drop down. Okay, but you're using the line of best fit. Last question. Now we have an equation for the line of best fit. So that equation represents this line. Okay, so that 1.87 is your slope, 11.2x is your y-intercept. When you're given an actual equation, now you're using the equation to plug x values in and give exact answers. So when the predicted amount of money spent on entertainment for a student who works 10 hours, okay, number of hours worked, so we're looking at 10 on the x-axis. You are not guessing at this point. We're going to actually go ahead and plug that in. So in my calculator, I'm going to take 1.87 times 10, that equals 18.7, and then add 11.26, and that's going to be $29.96. So I'm actually taking 10 and I'm plugging it in for x. Next question, what is the predicted amount of money spent on entertainment for a student who doesn't work any hours? Well, they didn't give me an x, I don't know what to plug in. Well, if you don't work any hours, that's working 0 hours. So that is you plugging 0 in for x. Well, 1.87 is 0, or excuse me, 1.87 times 0 is 0, plus that 11.26 will be 11.26. And then the last question, for an increase of 1 hour in time worked, what is the predicted increase in amount of money spent? Well, you could punch in like x equals 1 and x equals 2 and see how much they change. But for an increase in 1 hour in work, that is your slope. Your slope represents the rate of change for increase in a single x. So all you have to do there is, what's my slope value? My slope is 1.87. So $1.87, that is the amount change in 1 extra hour of work. Okay? Good luck on your homework. Keep working hard. Have a great weekend, and I will see you all on Monday.